Good day, everyone. My name is Samuel, and today we have a topic to consider function. Um, so, this topic is a topic that is very relatable. We apply it every day of our life. You will say, how so? Yeah. As we go on in the topic, I'm going to show you how relatable this topic is. But to move on, this is the objective of the lesson. At the end of today's session, this is what I expect you to be able to do by the end of today's session. And then this is the lesson plan. You should know. I'm going to start with what function is, then I'm going to majorly dwell on identifying function, which is through the ordered pair, table, graph, mapping diagram, and I'm going to give you an exit ticket, couple of work to do to show if you have how you understand the topic. Then after that, I'm going to give you sort of an exercise that you could do at your leisure. So this is basically how the plan is going to go. So let's start. Function. But before I start with identifying function, I want to say that function is a rule that assigns an input to a particular output. It's a rule that takes an input and matches that particular input to a specific output. Let me give you some instances to corroborate what I've just said. Take, for instance, you want to get a soda and you walk into a store, you go to the vending machine, and you know that Coke has different flavor. We have orange, we have apple, we have cherry, we have diet, we have zero sugar, we have peach. I mean, there are so much. So let's take, for instance, you want to get zero sugar. So you take your bottle, you go to the vending machine, and you click zero sugar or you press zero sugar. You would expect that what comes out is zero sugar, right? That is function. It matches an input, zero sugar, to a particular output. You don't press zero sugar and get something else. That's not a function. Let me give you another example. You go to your ATM to get some cash. And of course, you put your PIN, your 4-digit number. The moment you press enter, what you would expect is the machine should give you your cash, right? That is function. An input to a specific output. The input is that you put in your 4-digit number, and the output is that you get your cash. That is function. Okay, let me give you another example. For someone like me that plays guitar, well, I'm not a pro, kind of. I'm just trying my best. I know where to strike. I know the notes to strike to get do, to get mi, to get re, to get whatever I need to get. So I want to get do. That's do. An input is that I go to this particular note and I strike it. The output is that I must get a sound or a note that shows what? Do. If I come to this guitar 2 days to this time, 5 days later, 20 days later, and I strike the same note, I must get the same sound. That is input. It's assigning a particular input to an output. I can't strike that note and get something else, then it's no more a function. So that's basically what we are talking about. So let's quickly run through the notes. Um, okay, I'm going to pick my pen. So a relation is a rule that takes input value, just like I said, and assign them to an output value. You can represent a relation with a set of ordered pair. I'm still going to talk about ordered pair as we go on. I can determine whether or not a relation is a function by identifying the number of outputs assigned to each input. The input of the relation is called the x coordinate. That's what we call the x coordinate. The input, the digit number you put on your ATM, me striking the code, me clicking zero sugar, those are inputs. And that's what we call the x coordinate mathematically. But so the set of all inputs is what we call the domain. The set of all inputs. So if I have more than one x coordinates, if I have more than one input, a set of all inputs is what we call the domain. Okay. Now, the output is the y coordinate as expected. Now we are doing it mathematically now. We are bringing it from the real life situation now to math. The output is the y coordinate, and the set of all outputs is what we call the range. Is what we call the range. Okay. Now, relations can be represented in 4 ways. There are 4 ways that we can represent relations. The first one I will say is the ordered pair. Then we have another one, the table, in form of a table. It could be in form of a graph. And then, okay, I'm gonna clean this. Yeah, all ordered pair. I'm cleaning this also. Yep, this is table, graph, and it could be in form of mapping diagram. Mapping diagram. So these are the 4 ways you could see. So the ordered pair is when the x and the y coordinates are put side by side. This first number is the x coordinate. That is the input. That is the input. And the next one is the y coordinate. So when we have it in ordered pair, it's always as x comma y in this form. The x comes first, then the y after. The x coordinate is the input. The y coordinate is the result of the input. So, and it can be in form of a table, just like you see, and it can be in form of a graph. Then we can have it as mapping diagram, mapping input to output. So let's move on. Look at this. A function is a specific type of relation that assigns exactly one output to each input. I've said that before. When you go to your ATM, the output is that when you put your PIN, you should get your cash. It should be like that on a normal day. You know, if I say 2 plus 2, 2 plus 2 should be 4. You know, a particular input matching to output. So look at it. This is a function. How do I know it's a function? 10, 1 gives 10. Did you see that? The input is 2 and the output is 20. Did you see that? 3 gives 30. Did you see that? And 4 gives 30. Somebody is confused that, oh, how come 3 and 4 is giving 30? Yes, it can be. But the thing is, look at the second diagram and I will explain. Look at the second diagram. You have 7 giving birth to 15. Well, The same 7, which is the input, gives birth to 17. That is not a function. So what am I saying? The x value can only give birth to one y value. We don't care if the y value repeats itself. The y value can repeat itself, just like in the first diagram. So you could say that 3, 30, 4, 30. That's correct. It's a function. But you cannot have your x value repeating itself. Look at this second diagram. What I have here is like saying 7, 15, 7, 17. This is wrong. 7 gives 15. 7 cannot give 17 again. That's not a function. 7 can give 15 and another number also gives 15. It's okay. Just like what we have in the first diagram. 3 gives 30. Then another number, 4 gives 30. It's okay. But when you have your y value, your x value repeating itself, just like this second diagram, then it's not a function. Okay, let's move on. Let's look at how to identify function. Number 1, check each input value. So we want to use the mapping diagram now. Check each input value, and if an input value is mapped to more than one output value, then it's not a function. Just like I said earlier on. Look at this. This is an input value matched to this. Input value Q matched to N. Input value R matched to N. This is a function. It checks out. Look at this also. P is matched to X. Q matched to Y. Then R matched to Z. It's a function. Good. But look at the last one. You have P matched to X. Q, which is an input value, matched to Y. The same Q, which is an input value, matched to Z. Then it's not a function, because you have an input value matching to more than one output value. There should be a unique output value for an input value. So this third one, it's not a function. Okay, let's see. The second way of identifying function is by table, using table. So table can be used to represent relation. To determine whether a relation shown in a table is a function, consider how the members of the input correspond to the members of the output. Okay, let's look at the table we have here. We have two tables. Look at the input values here. I have -1, 0, 1, 2, 3. By the way, you remember I told you each of these input value is called the x coordinate. But all together, I will call them the domain. The set of all input value is called the domain. And the set of all output value is called the range. So look at it. -1 is matched to 5. 0 is matched to 3. 1 is matched to 4. And goes like that, which it's okay. And you would see something here that 1 is matched to 4. 3 is matched to 4. It's totally okay. We can have our y coordinate repeating itself. It's okay. Look at the second table. I have 3 matched to 0. I have 4 matched to 7. I have 5 matched to 10. I have 4 matched to 14. Did you see that? 4, which is the input value, matched to 7. The same input value, 4, matched to 14. It's not a function. So now I want to believe that you can easily recognize how to you can easily know what is a function, how to recognize a function from a table. The input value can not repeat itself, while the output value can repeat itself. The x coordinate cannot repeat itself, but we can have a repeating y. It's okay. Okay, let's move on. Now, this is using graph. How can we identify function using graph? You can apply the vertical line test. This is what we use when it comes to graph. If each value of x, if for each value of x, a vertical line passes through no more than once, not more than once, then the graph is a function. I'm going to show you a couple of examples real quick. But if the line passes through more than one point on the graph, then it is not a function. Let's look at some example real quick. Look at these graphs here. What does vertical line test says? It says that when you are given the graph, draw a vertical line, a straight vertical line on the graph. It is a function if the line touches the graph just one time, just one time. But the moment the line touches the graph more than one time, it is not a function. But mind you, it must be a vertical line. Let's take, for instance, this. I'm drawing a vertical line on this. How many times do we have this line touching the graph? 1, 2. It's not a function. It is not a function. It must, you could see that at every point in time when I draw my vertical line, it's touching it 2 times. It's not a function. Let's look at the second one. At any point where when I draw my vertical line on this, it's only touching one time. Look at it. This one time here, one time here, one time here. I mean, it's just one time. Then this is a function. This checks out. Look at this. If I draw my vertical line on this, it's touching how many times? 2 times. This place and this place. It's not a function. That is how to identify a function from a graph by vertical line test. Just draw your vertical line. If the line is touching the graph at just one point, it's a function. But the moment it's touching the graph more than one point, it's not a function. Okay, let's move. Then look at this also. If I draw my vertical, this is a graph, but a scattered graph. So if I draw my vertical line, look at it on this, it's meeting it 2 points. So it's not a function. This again, I have the line touching 2 points. It's not a function. But look at this. At every point when I draw my graph, my line rather, on this, it's just touching the graph only one time, one time, one time. No matter where or how I draw my vertical line on this, it's going to touch just one time. This is a function, whereas this is not a function. Okay, now I want to believe you understand the concept of function. What a function is a rule. A function is a rule that assigns an input to an output. Take note of something. You can have repeating y value. You can have repeating y value, but your x value cannot repeat itself. The moment you have repeating x value, it's no more a function. So I have for you exit ticket here that you should do. I'm going to give you, say, a few minutes to get this done. And then after the exit ticket, I have just this question, which I believe you should be able to do. Then this is a summary of everything I've said so far. This is summary of everything I've said so far. The guided notes. I have everything well stated there. A function, um, how to recognize the function from other pair, table, mapping, and it's a very summarized note for you, which I believe is going to be helpful. And then this further exercise, if you would at your leisure, you could get this done. So in the next class, we're going to go to another aspect of function, which is slope intercept form, and that is what we are going to be checking out in the next class. Thank you for staying with me. Catch you next class. Bye.